Unit 2 Design and Pre-Production. Lesson 2 Environmental Assessment Tools. Learning Objectives. In this lesson there will be explained the need of using environmental assessment tools during the process of eco-design, and from the recommended ones their aim and in which steps of the eco-design process they can be useful. For the simplest ones, some practical instructions for their design and use will be also explained.
The need recommended methodologies from less to more complexity are checklist, eco-design strategy wheel and life cycle assessment. Environmental assessment tools support the design team to check if they have applied the several eco-design strategies into a specific product, and also in which degree and if the global aim of life cycle environmental impact has been reduced with the new design.
Assessment tools can be monovectorial, energy demand, carbon footprint, or multivectorial, more than one environmental aspect. On the other hand, they can go from the simplest qualitative tools to the more complex quantitative ones. There are proposed 3 of these tools, increasing the complexity as the eco-design project progresses. Complexity depends on the needed input data, performance, sometimes with dedicated software, and the results that can be provided. This is because in the early stages the goal is oriented to the generation of ideas. Subsequently the possible specific actions are selected until reaching the design of the prototype, and quantitative data can be calculated, estimated to obtain more detailed product environmental evaluations. However, the choice of tools at each stage depends on the availability of resources, economic, data, time and qualified staff available that the company wishes to invest in the project. Checklist tools are very useful to verify if the team has considered all the possibilities at all the life cycle stages. It is a simple and cheap tool that can be customizable to each project, depending on the objectives. It is a good starting point, but it is not enough to assess the eco-design results. It can be complemented to be transformed into a very simple semi-quantitative tool, or to collect additional info. Besides, if it is not complemented by any kind of data added to perform an additional valuation of the degree of application, it is quite subjective. When defining the checklist questions, all the eco-design strategies must be considered and it is recommended to structure them according to the life cycle stages, defining as many questions as needed to cover all the perspectives of the problem and especially when considering the parts where the product design can be more complex. To ensure the usefulness of the checklist, try to orient the question to the type of answer you would need, and complement it requesting more info on the causes to find the real deal and propose more efficient solutions. Eco-design can be applied for a very innovative new product with any previous product reference in the company or the market, but this is not very usual. Always can be find an alternative to compare with our eco-design product, or idea of the product. To ensure a more equitative comparison, try to find a reference product with the same primary function, and collect information on its composition and use parameters. Try to answer all the checklist questions and collect more information when you need it. Even in the case you cannot answer properly all of them, the increase of knowledge will be a very valuable result.
Eco-design strategy wheel is a versatile tool or methodology. There are many variants and can, or should, be customized to each type of product to achieve a more focused assessment. It does not need any expensive and specific software. It can be simple or more complex depending on the number of parameters considered and the data needed to do the assessment of those parameters, and also it could be structured in difficulty levels or becoming from more qualitative aspects to include more quantitative ones depending on the design step. It can be developed to provide useful indicators to communication, Type 2 eco-labeling, environmental self-declarations. Final results can be represented into a graphic way, but to have the data originating these results, a complementary table should be performed. The valuation scale of each parameter can be subjective, but justified or based on a previous definition. It analyzes environmental aspects but not the related environmental impacts.
Identify and classify the environmental aspects of the product's life cycle by eco-design wheel axes. They could be redefined when needed but Breze and Van Hemel is recommended. Try to consider eco-design goals of the project when defining them. Identify the parameters to measure the degree of improvement success to each aspect, and the different levels of environmental preference. Decide the direction of the scale from 1 to 10 points. Usually less points means less impact, and establish the value corresponding to each level of parameter preference. Sometimes a reference value will be necessary, for example a medium weight of this kind of products to measure the percent of mass reduction. Establish a ponderation system of the different parameters and aspects involved in each axis, relative importance, to be able to achieve a unique punctuation. It must be coherent with the strategy and goals. Once fix the assessment rules, put them into practice. This tool is especially useful to compare alternatives or in a redesigning process. Put all the aspects and parameters into a table, first column or row, and fill following ones with the achieved points by each design alternative. Justify or keep the origin of the data used to obtain each parameter value, in order to review the assessment during/after the design process. Ponderate the parameters' punctuation to obtain an axis value and draw a spider diagram with them, one seri to each product. Life cycle assessment is an objective, science-based process for evaluating the environmental impacts associated with a product, process, or activity throughout its life cycle by identifying and quantifying the energy and materials used and wastes released to the environment, to identify and evaluate opportunities affecting environmental improvements. It can be used before starting, reference product assessment, during design, partial assessment to compare materials etc., and at end of the prototype development, detailed design, for the final verification. Life cycle assessment is the methodology used to develop the Type 3 eco-labels, Environmental Product Declarations, EPD. It requires an expensive software, and the methodology is quite complex, to be performed by an expert. Besides, it needs a large amount of quantified data, not always available. It analyzes both environmental aspects and the related environmental impacts. Two kinds of quantitative results can be obtained. Midpoint methods are difficult to interpret, but endpoint results are easier and useful to eco-design. The valuation is objective and the study uses to include an independent verification, if the external communication is part of the aim. Despite its powerful and good reputation at political and scientist level, it is a recent methodology, still under development. It has limitations, especially regarding available databases, and on the other hand not all the environmental considerations are quantified.
To develop a LCA is an iterative process represented by the following steps. Define the purpose of the LCA in the scope, product and its life cycle to be analyzed. Here the main reference unit of the system is established, the functional unit. Life cycle inventory. The material and energy inputs and outputs to each process of the life cycle are identified and quantified according to the functional unit. Environmental impact assessment. The quantified inputs and outputs, environmental aspects, are transformed into the related quantified environmental impacts they generate into the environment. Results are analyzed to identify of significant aspects and verify the integrity, sensibility and coherence of the LCA. Conclusions, limitations and recommendations. Evaluation of opportunities to reduce energy, material inputs or environmental impacts at each stage of the product life cycle.
The LCA provides the following results useful to the companies. Increase the knowledge of our system. To define the system boundaries and complete the life cycle inventories there is collected a huge amount of useful information. The endpoint environmental evaluation methodologies, the several impacts are transformed into a unique global punctuation, are specially useful to identify significant environmental aspects, materials, processes, etc., to be prioritized at the eco-design. They are also useful to check those improvements. The midpoint environmental evaluation methodologies stop at the objective evaluation steps, and provide an environmental profile according the different environmental impacts considered, used to develop the environmental product declarations. The eco-design needs the support of assessment tools to verify the degree of its application or the environmental improvement achieved. They are also useful to the environmental communication, eco-labeling. Those tools can go from the simplest qualitative, checklist, to more complex quantitative ones, LCA. The selection depends on the aim and step of the eco-design project and on the other hand the availability of resources.